All right, guys. Welcome. It is Sunday, September 1st, and noon, where I'm doing my live session on solving linear equations or linear inequalities, which is section 1.7. Yes, 1.7. Before I get started, tomorrow is Labor Day. Grantham University is closed tomorrow, so I will not be available for questions or anything like that because it is a day off for me. So anything that you email me once I stop working today, going through discussions, all that stuff, you'll get a response on Tuesday. All right, so let's get started by sharing my screen. All right, so here we go. Solving linear inequalities in one variable, 1.7. So 1.7 covers representing solutions of linear inequalities in a variable, basically how you give the solution, using properties of inequalities to write equivalent inequalities, solving linear inequalities in one variable, solving absolute value inequalities, and using linear inequalities to model and solve real-life problems. So today I'm going to go through the process of solving linear inequalities and solving absolute value inequalities. So first we need to talk about interval notation, because this is how we write our solutions once we've solved. So this is actually taken from section P.1, which we covered in week 1. And so interval notation looks like ordered pairs, but we use brackets or parentheses or some combination of each. So you know whether something is an ordered pair or interval notation based off of context. So that's how you know the difference, because the notation may look the same. So bounded intervals basically means you are between two different numbers. So when we solve inequalities, we're going to solve and get something that looks like the inequalities that are listed here. And then you're going to convert it to the notation in the first column there. And that's interval notation. So I recommend just having this handy, because if you understand what the inequality looks like, then you can give the notation. The key is basically if it's a less than, you use a parenthesis. If it's less than or equal to, you use a bracket. I think of the less than meaning that the endpoints are not included, and so you're curving away from the endpoint because you can't touch the endpoint. While if it's less than or equal to, the endpoints are included, so that's a hard wall that you can touch, and so that's why it's a bracket, because that's something you can actually touch. So that's how I remember these things. So closed intervals are considered if they've got brackets on both sides. Open intervals have parentheses on both sides, and then you can have a combination of bracket and parentheses depending on the symbol. Unbounded intervals are where we go on to infinity, basically, that we're greater than a number or less than a number, or some combination, greater than or equal to, less than or equal to, and there is no end point on the other side. So those go towards infinity. Because infinity is not something that you can actually reach, that always uses a parenthesis, because you cannot actually reach infinity. It is not a hard number. So here are some examples of whether you use a bracket, and that's greater than or equal to or less than or equal to, or whether you use a parenthesis. And the key is we always do the smallest number, comma the largest number. So if you are going to the left and it's less than, then you're going to have infinity, negative infinity on the left. Well, if you're going to the right, it's going to hit positive infinity. And if your solution is all real numbers, then your notation would be negative infinity to positive infinity to indicate that everything is part of the solution. So in order to get to solving inequalities, once we understand how to write our solutions, we need to then take a look at properties. So we've got the transitive property, which if A is less than B and B is less than C, then A has to be less than C. Addition of inequalities, it's like the addition property of equations, except that it applies to inequalities. It basically says that you can add inequalities together just like you can add equations together. So if you have A less than B and C less than D, you can add A plus C and B plus D, and you'll still have the less than. And then you can also add a constant on both sides, and your inequality will still hold. And then we've got multiplication by a constant. And so we can multiply both sides just like we can with an equation, but with multiplication or division, there is a little caveat here, and that is if your number is a negative. So if you multiply both sides or divide both sides by a positive, your inequality stays the same. But if you are multiplying or dividing by a negative number, then the inequality reverses direction. So if it was less than, it becomes greater than. So it reverses direction if you are multiplying by negative. So that is the one thing to pay attention to, because a lot of people forget that step. And why that is true, let's say I have 2 less than 5. If I multiply both sides, let's say by -1, that would be -2 and -5. Well, -2 is not less than -5. -5 is less than -2. So you have to flip the inequality to get something that's still true. So that's why if you are multiplying or dividing by negative, you have to reverse the inequality. If you're adding a negative, it doesn't matter. It's just with the multiplication and division. Okay, so steps for solving a linear inequality. So step 1 is to use the addition and subtraction properties just like you would for an equation. The one thing is with an equation, it doesn't matter which side the variable on, but when we have inequalities, the variable needs to be on the left. So always put your variable on the left side and make sure that your numbers are on the right. Once you've done that, then you need to use the multiplication and division properties where you're dividing or multiplying to remove the coefficient. And just remember, if a negative is involved in that step, the inequality reverses. And then once you've done that and you've got x less than, greater than, or something, then you give the answer in interval notation. And if it asks for you to graph, or if it's helpful for you to graph, you can go ahead and do that. So here's one where we're going to solve and graph, so you can see the connection there. So we've got 3x plus 1 greater than or equal to 2x or 2 plus x. So because I want the variable on the left, I always move my variable first. So I've got plus x, so I'm going to subtract x on both sides. So 3x minus x is 2x. So I have 2x plus 1 is greater than or equal to 2. And now I'm going to subtract the 1 to get that on the right. So minus 1 on both sides. I get 2x is greater than or equal to 1. So now that I've used the addition properties or subtraction properties, I now need to divide, because I need to divide both sides by 2. Because I'm dividing by a positive, I don't have to worry about reversing the inequality. So this is going to give me x is greater than or equal to 1/2. So if we look at this as a graph, I'm going to just put a number line here. I'm going to just put 1/2. And I have infinity and negative infinity. If we are greater than or equal to, so we're greater than, so everything to the right is greater than 1/2, and we can be equal to 1/2. So because we can equal 1/2, that is a bracket. The bracket is used whenever you have an equal to part. And the bracket faces the direction that you were shaded. So I'm going to have a bracket facing to the right because that's where I'm shaded. And then if we go to infinity, that's a parenthesis facing the other direction. They're always going to be facing inside towards what's shaded because we can't actually reach infinity. So our solution in interval notation, now that I've graphed, is bracket 1/2 because that's our left endpoint. Our right endpoint is infinity with a parenthesis. So it usually helps to graph in order to write the interval notation, because you can see the connection between the interval notation and the graph versus memorizing what the interval notation looks like based off of the inequality. Okay, so example 2 here, we have a compound inequality. And a compound inequality is when you have two inequalities and they are combined. So instead of having a left and a right side, we have a left, a middle, and a right. The rules apply for this, and we solve it just like we would do anything else, except that instead of doing it to both sides, aka left and right, we have to do it to three sides, left, middle, and right. So we have -1 is less than or equal to negative parenthesis x minus 4 parenthesis less than 7. So first, when we're solving this, we want to have x in the middle, because so we're going to have x, our goal is to have x in the middle for a compound inequality, rather than being on the left side. So first I'm going to distribute the negative through the parentheses. So I have -1 less than or equal to negative x plus 4 less than 7. My pen keeps, there we go. Sometimes my pen doesn't make smooth strokes. Okay, so I want my x in the middle, so I need to remove that 4 that's in the middle with it. And if it helps you, you can kind of highlight so you can see where the middles are if you get lost in the symbols. So I need to subtract 4, and I need to subtract that from the left, the middle, and the right. So you're going to do it 3 times. So that will give us -5 is less than or equal to negative x, which is less than 3. I'm going to just highlight here again so you can see that we have a left, a middle, and a right. Now I want x, I don't want negative x, and so that means I need to divide everything by -1 to get rid of the negative. Because I'm dividing by -1 and I'm dividing by a negative, I have to change directions of the inequalities. So I'm going to just put little arrows down so that you remember to do that. So -5 divided by -1 is 5. Now I have to change the direction. Now I have x, change direction, and -3. So now I have 5 is greater than or equal to x, which is greater than -3. Now generally, we read these left to right with less than symbols. So if you want to read it that way, you then have to reverse the whole thing, sort of like a mirror image. So because we want to have the smallest number on the left. So that's -3 less than x less than or equal to 5. And you may be wondering, well, why didn't we just keep the symbols the same and switch the order of the numbers? Well, notice that the order of the symbols also switched. So what was an equal to on the left is now an equal to on the right side. So there's a lot of stuff to kind of keep track of. And so it's best to first reverse the inequalities when you're dividing by a negative, and then, if needed, reverse the entire inequality. You don't always have to do that last step. So that's why I don't try to do it all at the same time, because sometimes you don't need to do that. So now what we have is we're saying that x is between -3 and 5, but we can include 5. So I'm going to graph my number line and put -3 and 5. And we're saying that x is between there. It's greater than 3, so we can't include 3. But it is less than or equal to, so we can include 5. So if I'm not including -3, that's going to be a parenthesis, and it needs to face where I have shaded, so that's a parenthesis. And then at 5, we're including 5, and it needs to face the shading, so that's going to be a bracket facing to the left. And so then in interval notation, we have -3, 5 bracket. So you just read it left to right once you have your graph. Okay, so if you're wondering why I'm not asking questions, it's because right now nobody else is on here and I'm just talking to myself. So that's why this is going so quickly. If you do have questions when you're reviewing this after the fact, feel free to send me an email, or you can even comment on the video if you want, if you're watching on YouTube. Okay, so now we've got absolute value. So this is also from P.1. It's just the definition of an absolute value. Where so far when we've been dealing with absolute values, we've been just saying, okay, the absolute value makes a number positive. The other way to look at it is that what's inside the absolute value can be positive or negative. And so that's sort of what this is saying. And we're going to use that alternate way to look at it in order to solve inequalities that involve absolute values. And we actually use that same property in 1.6 when you're solving absolute value equations by setting up two separate equations, one with a positive version and one with a negative version. So we're doing the same thing here with inequalities. So when we have inequalities, though, it's a lot trickier than just the equal sign where you have two equations, because here the inequality, if you're adding a negative, then that also changes the direction of the inequality symbol. So rather than trying to figure that out all at the same time, you can think of it as there are 4 different possibilities that you can see involving absolute value inequalities. And then there's 4 different ways that you can write those. The way I look at it is that if it's a less than or less than equal to, it creates a compound inequality, which we just solved. And if it's a greater than or greater than equal to, it creates 2 separate inequalities separated by an or. The or is important for finding the solution, because or means we are unioning the solution. It can be one or the other. So we're not looking for any overlaps of solutions. We're just saying, okay, wherever we've colored, that's our solution. So for these types, I strongly recommend graphing in order to figure out your solutions, because of the fact that we have what is called a union going on because of the or symbol. So it's either one or the other, or it could be both. So that's what that means, basically. So I've got examples going through all 4 of these possibilities here. So I'm going to just start from the top one and going down. So form 1, absolute value of something is less than a number, essentially, or less than something else. So I've got 2 examples here. So the first one here, absolute value of x minus 7 is less than 5. So if it's a less than, we turn this into a compound inequality. So I've got x minus 7 is less than 5, but then I also have the other side with the negative 5. And then I keep the less than symbol in between those. So I have negative 5 less than x minus 7 less than 5. And now you're solving for x in the middle. So I'm going to add 7 to the 3 sides. So negative 5 plus 7 is 2. 1x less than 12. And so now I'm solved. And now graphing, I have 2 and 12. My x is in between 2 and 12, but does not include 2 and 12. So those are going to be parentheses. And the parentheses are facing where I'm shading. So my interval notation is 2, 12 with parentheses. See, that's one where it looks like an ordered pair, and so you have to know by context, we're not graphing, we don't have 2 variables. If there's 2 variables, x and y, then that's an ordered pair. But we solve something with one variable, so that's interval notation. So you have to know by context based off of how many variables you have. Okay, now the second one here, we've got 1 minus 2x inside absolute values less than -5. So same thing, 1 minus 2x less than -5. And then on the other side, I'm going to take the opposite, so now that's going to be 5. So I'm going to we've got my 3 sections here. I need to get my x by itself in the middle. So first I need to get rid of the 1. So I'm going to subtract 1 from 3 sides. 5 minus 1 is 4, less than -2x, less than -6. Now I'm going to divide everything by a negative, which will reverse the inequality. So I'm dividing everything by -2. So 4 divided by -2 is -2, greater than x, greater than 3. And now we still have the less than, or the small. The key here is we really want to have the smaller number on the, or we want to have, let's see, it's easier to think of as read it left to right. So we want to do the mirror image. So that means I've got 3 less than x less than -2. And now let's think about what this means. 3 is less than x, which is less than -2. Is 3 less than -2? No. We have something that is impossible. 3 cannot be less than 2. Because when you read these left to right, it's basically whatever's on the left has to be also less than whatever's on the right. That's that transitive property. So this is impossible. So this means there is no solution, which we usually hate with a 0 with a slash through it specifically. So that's why never write your zeros with a slash through it, because that means no solution as opposed to the number 0. There's a difference there. We could figure this out immediately from the way the whole equation is set up, because at the very beginning, with the absolute value of 1 minus 2x, which absolute value is always positive, less than a negative number, less than -5. And a positive is never less than a negative. So even before solving it, you could say, oh, wait a minute, my absolute value is less than a negative. That can't happen because the absolute value is always positive, so there is no solution. Okay, so now let's look at what happens when you have a less than or equal to sign, because if you have the equal to there, that can throw some of these things off. You can get some interesting things. So first, I have absolute value of x minus 8 minus 2 less than or equal to 14. So before we rewrite this into the compound inequality, we first have to get the absolute value by itself. So that means that minus 2 I have to add to both sides before I do anything else. So that gives me the absolute value of x minus 8 is less than 12. Now it's got that less than, so we're making a compound inequality. So I have x minus 8 is less than or equal to 12. And then on the other side, I put negative 12 is less than or equal to. So now, with my highlighter, so we can see the 3 sections, I need to get x by itself, so I'm going to add 8 to everything. So negative 12 plus 8 is negative 4, less than or equal to x, less than or equal to 20. Okay, so now I'm going to make my graph. I'm going to put negative 4 on my number line, 20 on my number line. X is between those two numbers, literally. And then we can include, because of the equal to part, so we can include both of those numbers. So those are going to be brackets facing where we've shaded. So in interval notation, that gives me a -4 with a bracket and a 20 with a bracket. And that's our solution. Now the second example here, this is a special type of thing because we have an absolute value less than or equal to a 0. So 0 doesn't have a positive or a negative version. So we would not need to create a compound inequality. We can just ignore essentially the absolute values, and then basically you would set it up because -0 is the same as +0. So what we have here is 0 is less than or equal to 9 minus 2x, or less than or equal to 0. Well, the only way for 0 on the left to be less than or equal to 0 on the right is if they're equal. So basically we're saying 9 minus 2x is equal to 0. Because there is no other less than part because both sides are the same. So we're actually solving in here an equation because now we have an equal sign. And if you look at what we originally have, 9 minus 2x absolute value less than or equal to 0, it's never less than it's 0. So that part doesn't even really matter, but it can be equal to 0. So that's the only part we really care about. So we're just solving where it's equal to 0. So if I add 2x to both sides, so that I don't have to deal with any negatives, I get 9 is equal to 2x. And then we divide both sides by 2. You get x is equal to 9 halves. When we graph this, it is just a dot. Basically, at 9 halves, we only have one solution. It's just a closed circle. And when we put this in interval notation, you actually use set notation. And we just put it in a set with a single number, 9 over 2. Because if the absolute value is not going to be less than 0, so it can only be equal to 0. If it had been a less than without the equal to part and said less than 0, that would be another no solution because it can't be less than 0. But we can be equal to 0, so there is a solution here. It's just a single number. Okay, now form 3 where we have the greater than symbol. So I've got two possibilities here. First one, again, because before I do anything, I have to get the absolute value by itself before we do anything else. So I have to subtract the 3 from both sides first. So that gives me the absolute value of x plus 14. Make the better plus sign. There we go. Plus 14 is greater than 14. Because 17 minus 3 is 14. Now, if it's a greater than, we end up with two separate inequalities to solve with an or in between them. We have x plus 14 greater than 14, where you basically are ignoring the absolute value sign. And then you have x plus 14 is less than negative 14. So we have to switch the absolute value, or we have to switch the inequality, reverse it because of the negative there. So now you solve each of these for x. So I'm going to subtract 14 from both sides. We get x is greater than 0, or when I subtract 14, x is less than negative 28. So now when I graph, let's take a look at what this means. I'm going to put negative 28 on here and 0. So x is greater than 0, so that's to the right of 0. Or x is less than negative 28, so that's to the left of negative 28. So we have two separate sections here that are solutions, and we combine these using the union symbol. So on the left, my left endpoint is negative infinity, comma, negative 28, and then I have a parenthesis because it's a greater than, not a greater than or equal to. And then I have a gap, so I have to connect those with the union symbol, which is a big U. And then my next endpoint that I hit is at 0, which is not included, so that's 0. And then that goes to infinity, which also has parentheses. So our solution, we have two separate pieces. Our solution could be in either one. It can't be in both because they don't overlap, but it would be in one or the other pieces. And so any x in those sections can solve this problem. Okay, now let's look at absolute value of x over 2 greater than -6. So same sort of thing, absolute value already by itself. So now we create two separate inequalities. We have x over 2 greater than -6 and x over 2 less than 6, because you're taking the opposite of your number, and that involves multiplying by a negative basically, so the inequality flips directions, it reverses. Now to solve both of these, we multiply both sides by 2 to get rid of that fraction. So I get x is greater than -12, or x is less than 12. So I don't have, because I multiplied by 2, negative, I don't, or it was a positive, I don't have to worry about reversing things. So let's graph what this means. So I'm going to put -12 and 12 on my number line. And now highlight. So x is greater than -12. So that's to the right of -12. X is less than 12. So that's to the left of 12. Well, now everything is highlighted. So that means our whole number line is the solution. So in interval notation, make sure I've got the pen, it says -infinity to infinity, because our left endpoint is -infinity, our right endpoint is infinity. So the whole number line is the solution. This is all real numbers for the solution. You can figure that out from the very beginning. You have an absolute value greater than a negative. Absolute value is positive, greater than a negative. Well, a positive is always greater than a negative, so it doesn't matter what x is, it's always going to be true. So you don't even need to solve. You can look at that and think about it critically and say, wait a minute, this is always going to be true. So these absolute value problems involve a lot of critical thinking and considering, what do these equations mean, what are they telling you, before you just go and solve, because you can save yourself some work. Okay, now the last form is where we have an absolute value greater than or equal to a number. So now the first one here, I've got 2 times if the absolute value of x plus 10 greater than or equal to 6. So 2 times an absolute value. You are not allowed to multiply through absolute values. It's not a parenthesis. You can't distribute through there. It does not work that way. So what we need to do is divide both sides by 2 first in order to get the absolute value by itself. So that gives us the absolute value of x plus 10 is greater than or equal to 8. Now I'm going to set up 2 separate equations. I have x plus, or inequalities, x plus 10 is greater than or equal to 8, or your second one, x plus 10 less than or equal to -8. So you switch the sign and you reverse the inequality. So now I solve both of these by subtracting 10 from both sides. We get x is greater than or equal to -2, and x is less than or equal to -18. So now if I look at this on my number line, I have -18 and -2. I'm going to label my infinities. So x is greater than or equal to -2, so that's to the right and includes 2. X is less than or equal to -18, so less than is to the left of -18 and includes 18. So now, as far as the interval notation goes, at negative infinity, that's the left side, that always has a parenthesis, comma, then my highlight stops at negative 18, and it's included, so I have a bracket facing towards where I've highlighted. Then I have to union the two pieces together because we have two sections. My next endpoint is at negative 2, and that's included, so it's a bracket facing towards where I've shaded. Then comma, and then I end at infinity, which always has a parenthesis, and that's going to face the shading. So now we've got two separate sections, which are the solution to this problem. Okay, so now last one here. I have absolute value of x minus 3 over 2 is greater than or equal to 0. So again, two separate inequalities here. So we have x minus 3 over 2 greater than or equal to 0, and then x minus 3 over 2 less than or equal to 0. Now remember that less than or equal to, the less than part, well, the x could be less than 0. That's fine because it's not an absolute value. Never mind what I was just about to say. All right, so to solve both of these, we can multiply both sides by 2 to get rid of the fraction. So that would be x minus 3 is greater than or equal to, then 0 times 2 is still 0. And then x minus 3 is less than or equal to 0. So now I add 3 to both sides. We get x is greater than or equal to 3, or x is less than or equal to 3. Now I'm going to draw my number line, and I only have one number here, 3. And so when I highlight, I'm greater than or equal to 3, so that goes to the right. And I'm less than or equal to 3, which goes to the left. So the whole thing is highlighted. So this is another one where it's all real numbers for your solution, because your absolute value here is always greater than or equal to 0. That's always going to be true because you have a positive greater than or equal to 0. And that's always true. Now, if it had been greater than 0 without the equal to part, then 3 would not be an answer, and your answer would be everything except 3, because we don't include 3. So that would actually look a little different. So to basically summarize some of these special cases that we have, the ways you can get no solution: if your absolute value is less than 0, the absolute value is less than negative, or the absolute value is less than or equal to negative. You can get infinite solutions if your absolute value is greater than or equal to 0, if it's greater than a negative, or greater than or equal to a negative. You get one solution if your absolute value is less than or equal to 0, because essentially you're just solving absolute value equal to 0. And then you get all real numbers except something when your absolute value is greater than 0. So those are special cases that you have to pay attention to. And you can also figure it out using log once you have your solution and asking yourself what that means. So if you have any questions, you can give me a call, you can give me an email, you can send me a chat message, and I look forward to hearing from you guys.